Hello, pre-calculus. Welcome back. In this video, we're going to discuss how to graph a rational function, and I'm just going to go through the steps with you here. This is slightly different than how your textbook approaches it, but your textbook those steps will also work just fine. This is just how I like to do it. So you can do this method, you can use the method in your textbook. As long as you get the right graph at the end of the day, you're okay. So my first step that I like to do is I just factor everything. I factor the numerator and the denominator. So let's do the factor numerator. Instead of calling this first, there's going to be a lot of steps here. So I'm just going to call this step one. Step one. And you might hear my baby in the background for this. She woke up for her nap. So if you hear her, I apologize. So we're just going to factor the numerator here. I have 3x squared minus 17x plus 10. And I know that's going to factor into two linear factors. To get 3x squared, I know I'll have to have 3x and x. And I notice here also that my last two terms will have to multiply together to be 10, but then I'll have to add up to be negative 17. So this is the guess and check method. You can use any method you like to factor here. So I'm going to say, I see that negative 17. What about a negative 5 here? So that the 3x and the negative 5 will give me negative 15x. And then I know this 10, so let's say maybe plus 2. And then I'm just going to kind of mentally check and make sure I'm on the right track. That would give me 3x squared. That gives me negative 15x plus 2x, so that'd be negative 13. And this would give me negative 10. Oops, that's not going to work. So what I need to change actually is I need to change this last value to be a negative sign. Because that's how I get the negative 10, as I'll have a negative times a negative. And we've done it. So that's the numerator. Step 2, I'm going to, you might have guessed already, factor my denominator. And so my denominator is 2x squared plus 3x minus 2. To x and x. And so again, I know that I'm going to have, let's see, plus 2 minus 1. Let's try that out. So 2x times x gives me 2x squared. 2x times 2 gives me 4x. Negative 1 times x gives me minus x. And then that gives me minus 2. So my 4x minus x gives me positive 3x, and we're good to go. All right, so now we've got everything factored, we're ready to kind of think a little bit critically. So step 3, I would say rewrite my function using these factors that I just found. So now here's what I have for my function. I have f of x is equal to 3x minus 2 times x minus 5 divided by 2x minus 1 and x plus 2. Now I'm going to find my domain of my function. So step 4, I'm going to find my domain. So I know here that to do that, I'm going to set my denominator equal to 0. So we have 2x minus 1 times x plus 2 is equal to 0. 2x minus 1 is 0, or x plus 2 is 0. Add 1 to each side. And I get 2x is equal to 0. It's equal to 1. I just added 1 to that side. And I divide each side by 2. So I get x is equal to 1/2. Here I subtract 2 from each side, and I get x is equal to negative 2. So my domain is negative infinity to negative 2, union negative 2 to 1/2, union 1/2 to positive infinity. And now I'm going to take a look at my function, and I'm going to find my vertical asymptotes because they're very related to the domain. So step 4, we found the domain. Step 5, we're going to look at vertical asymptotes. I'm going to abbreviate that V dot A for vertical asymptote. So what I want to check is I want to see, are either of these discontinuities removable? If they're removable, we will not have an asymptote. But if they're not removable, we'll have asymptotes at those two locations. So they would be removable if they were part of some common factor that I could cancel like that. But I see that they're not. I don't have any factors in common between my numerator. I'll highlight that in green. If I look at my numerator and my denominator, I actually don't have anything in common. So that means I have vertical asymptotes at x is equal to 1/2 and x is equal to -2. And remember here, because I have them at 1/2 and -2, that I'm going to have the situation where my graph looks like this around the asymptote. One side is going up towards infinity, one side is going down towards negative infinity. So those are my vertical asymptotes. Step 6 that I check for, I want to check and see what horizontal asymptotes I have. So if we take a look at our function, we have a degree of 2 in the numerator and a degree of 2 in the denominator. So let me show you what I mean by that. Before we factored it, we had this form. I hear my dog about to start barking, guys. Apologies if that happens. So we have our numerator and denominator. The leading coefficients are 3 and 2. And so I'm going to have a horizontal asymptote. See, my degree is the same here and here. So I will have a horizontal asymptote at y is equal to 3/2. That'll give me a horizontal asymptote. So now I have these 3 asymptotes. That's going to tell me a lot about how to graph my function. I also want to look for some particular points. So let me pull up, I'm trying to decide if I want to graph this by hand or show you on Desmos. My handwriting's so bad, I think it's better to show you on Desmos. So here's the answer. Gasp! Don't worry. We're kind of going to do it by hand a little bit so you can see how that works. But so I have a vertical asymptote of 1/2. I have another vertical asymptote of -2. And I have a horizontal asymptote of y equals 3/2. And so I want you to kind of see y equals 3 divided by 2. And I'm going to change each of these asymptotes. I'm going to give them red dotted lines, just so that we kind of know we're talking about asymptotes here. And so we know our function is going to have to do with these asymptotes here. Remember, the vertical asymptotes will never be crossed. The horizontal asymptote, we may actually cross. So we'll have to see how that goes. The next thing you want to do is you want to go ahead and find your x and y intercepts. I'm going to find my y-intercept first, then I'll find my x-intercepts, and then we'll be ready to graph. So, to find our y-intercept, we plug 0 in to the function. So we take f of 0, and then we can use either our factored form, or we can use our non-factored form. Doesn't matter. They're both the same function. And here I'm just plugging in 0 everywhere that I see x. And I see that I end up with 10 divided by -10, which is -1. So I have a y-intercept at 0, comma, -1 is my y-intercept. And let's go ahead and plot that on Desmos. Our intercept will be at 0, comma, -1. And we'll go ahead and label that. That's our y-intercept. Now we should find our x-intercepts. For that, it's actually easier to use this factored form. To find your x-intercepts, what you're going to want to do is take your numerator and set that equal to 0. So to find your x-intercepts, we're going to take 3x minus 2 times x minus 5 and set that equal to 0. We're going to take 3x minus 2 times x. Oh, I already forgot what it was. Got to double check. What's my numerator again? X minus 5. Phew. And we're going to set this equal to 0. And this is going to give us our x-intercepts. Then you write the instructions for the steps. You can have it for your notes. I think we're at step 8. That's a lot of steps. This is your x-intercept. And what we did was we set our numerator equal to 0. And we don't set the denominator equal to 0 because that would tell us where our function is undefined. So we get 3x minus 2 is equal to 0, and x minus 5 is equal to 0. So we'll add 2 to each side and get 3x is 2, and divide by 3 on each side. Get x is 2/3. We add 5 to each side, and we get x is 5. And so now we have our x-intercepts, 2/3, comma 0, and 5, comma 0. These are our x-intercepts. And I'm going to go ahead and plot those into Desmos. 2/3, 0, and 5, 0. So we have our point, 2/3, 0. Oops. Our point 2/3, comma 0. That's an x-intercept. And then our point 5, comma 0. And that's also an x-intercept. And we have almost everything we need right now to be able to graph this function, to be able to check this graph. So let's take a look at what we have so far. We have x-intercepts here and here. We have a y-intercept here. I know that I'll never cross my vertical asymptote. And I know that over time, as I get closer to infinity, that I'm going to approach this horizontal asymptote. So let me show you guys how you would go ahead and complete a graph like this. Let's see how we would complete a graph like this. So here's how I can fill in this graph. So you have to use a little bit of your creative license here to figure out how this graph works. So you know that the graph crosses at the x-intercept here and here. And you know that as we go towards infinity, we approach this horizontal asymptote. So we can kind of fill in that it goes down some amount and then comes right back up and goes off towards infinity in that way. And notice we have our beautiful vertical asymptote here, which it must not cross. So then the only option here really is to just go up, and look something a little bit like that. We know that the graph crosses our y-intercept here. But it also, notice how there are no x-intercepts in between these vertical asymptotes. So there's no way that our graph can go up in between these two asymptotes. Our graph has to actually go down. So we can kind of fill that in here. Fill that in here. We also know that we have something going on with this graph over here. Something's happening over in this region. We know that as we go off towards infinity, we approach that horizontal asymptote. And we know that as we go towards this vertical asymptote, that we shoot up and the graph kind of touches infinity. And so this is what we would call a sketch of the graph. Because there's some information that we don't really know for sure. We're just kind of guessing. Like I filled in this little loop-de-loop down here, this little chunk of the curve that's below the x-axis. I actually don't know how far that goes down. It could go down really far. It could go down just barely below. I don't really know. All that I know for sure is that I'm going to touch at the x-intercepts here, and then I'm going to have this behavior close to the asymptotes. So this would be a perfectly acceptable sketch of the graph. Let's see how we did. Let's compare to the actual answer. I'm going to save it and see if we did really good. So let's take a look. Here's the actual function we were working with. Oh, I labeled our y-intercept wrong. Guys, look what I did. Our y-intercept, I labeled it as 0, -1, but it's actually 0, -5. I must have made an error in my math finding that y-intercept. Wah! Oh, well. So let me tell you, if you made that error, if your y-intercept was wrong, here's all the things that I'm giving you points for when I see a graph like this. You get points for the correct intercept, or for the correct vertical asymptote at 1/2. You would get points for your correct vertical asymptote at -2. You would get points for your correct horizontal asymptote at 3/2. I would have taken off probably a point for getting the y-intercept in the wrong place. Your x-intercept is correct, so you'd get some points there. And for this one, you'd get some points. And then notice how the generic shape is close to what we sketched. I would give some points for that. So if this was a 10-point problem, I would probably take off a point. That'd be 9 out of 10, Sarah, because you made a miscalculation in your y-intercept. So if you caught my error and you see what my mistake was in the y-intercept, comment below and let us know where the y-intercept should be. All right, I hope that was helpful. If you guys like, we can do another example in class. Please come prepared with your questions, and we'll do our best.